All right, ladies and gentlemen, let's get into what is really chemistry, okay? Chapter 1 was sort of an introduction, had a lot of general science information that's important, but doesn't really cover what chemistry is really going to be all about, right? We covered the general overall chemistry is the study of matter and its changes, but let's talk a little bit more about that here in Chapter 2. So, again, Chapter 2, we have our objectives, things that we need to be aware of and be able to do, and we're done learning about the information in this chapter. We're talking about the properties of matter, we're talking about mixtures and elements and compounds, and a little bit about chemical reactions. All of this is sort of an introduction to the things that we're going to be talking about the rest of the way this year. So this is sort of our foundation chapter, okay? So let's start with properties of matter. Now, we talked about this back in Chapter 1. Matter is anything that has mass and takes up space, right? Anything that has mass and volume is considered to be matter, and that's the kind of stuff that we study in chemistry, right? Everything that's made out of mass and space, which is virtually everything that you can see around you right now, right? All of that stuff is matter. That's what we learn about here in chemistry. So how do we classify all of that stuff? All right, there's lots and lots of stuff out there that we have to classify. So we have to use its properties to do so. One way we can look at the properties of matter is to think about whether they are extensive or intensive properties, right? Extensive properties are properties that don't depend that do depend on the amount of matter. And then the intensive ones would be the ones that do not, okay? So extensive things would be things like how much mass is there? How much volume is it taking up, right? The things that depend on how much you have of that. But the intensive properties would be more like color. Doesn't matter how much of it you have, right? The water's the same color whether you have a drop of it or whether you have an ocean of it. Okay, the melting point of ice is the same whether you have a tiny little ice cube or whether you have a huge glacier. Okay. Identifying a substance, when we say the word substance, we're being very clear as to what we mean here. A substance is matter that has a very uniform and definite composition. So in other words, it's made out of all one thing. That's what a substance is. So when we mention that word, and we're going to mention that word quite often this year, we mention that word, we're talking about a substance that is the same throughout, right? Definite composition, it's uniform, same throughout. Now that's going to be different than when we talk about mixtures, okay? So every sample of a substance means it has identical intensive properties. Like I said for water, right? It doesn't matter how much water you have. Its color, its melting point, properties like that are the same. Okay? That's definitely not water, right? Definitely not water. The other way that we can look at properties is we can think of them as physical or chemical. Right? So all matter out there has a set of physical properties. These are properties that can be observed without changing what it's made out of, right? That's what composition means. It means what it's made out of. So anytime that we want to figure out what is that matter like, what is that object like, right? Can we describe it without changing what it's made out of? Right? Of course, there's lots of ways to do that, right? You could mention or describe the shape of something. You certainly don't have to change what it's made out of to describe its shape, or its size, or its color, right? And like, for instance, these objects that are on the screen right now, I can tell that they're blue, right? I didn't have to do anything to them to describe that, right? I can simply describe that they're blue. I can describe that they're circles. I can even describe how big they are, right? Here's a fun little thing, okay? Which of the circles in the middle is bigger, right? It turns out that a lot of people would say that this one is the smaller one and this one is the bigger one. They're the same size. Those little circles that are in the middle of each of those is actually the same size as each other. Of course, why does this one look smaller than that one? Because of what it's surrounded by. You always look smaller when you're surrounded by big people. You always look big when you're surrounded by small people. We also have physical properties like mass. I know that's an extensive property, but it's still something that is a physical property, right? I could have something on a balance or on a scale, and I could figure out its mass without changing what it's made out of, right? Or the volume of it, or the temperature of it. I can measure the temperature. I could put a thermometer in something, and I can measure its temperature without changing what it's made out of, right? Without changing its composition. So all of these are examples of physical properties, and there are certainly a lot more than this. These are probably some of the most common ones that we think about. So if somebody were to give you a table of different substances, like you see here, right? We have a bunch of different substances. Remember what substance means? So all of those things that you see in this table are all made out of exactly the same thing, right? We call it neon because it's made out of all neon. There's nothing else in it. It's not mixed up with something else, or oxygen, or chlorine, or ethanol, or so on and so forth. Okay? So all of these substances have a listing of some physical properties. Their state of matter, whether they're gases or liquids or solids, what color they are, what their melting point is, and what their boiling point is. So if you observe this table, you kind of look through all of the information that's on here. Let's see if we can't answer a few questions about what we see here. Which property can most easily distinguish chlorine from the other gases? So I want you to take a moment. I want you to take a look at chlorine. Right? So chlorine, it says, is a gas. It said it's greenish yellow. It has a negative 101 melting point and a negative 34 degrees Celsius boiling point. Right? Which property can most easily distinguish chlorine from the other gases? So if we want to easily distinguish it, seems obvious. Between the three gases that are on this list, color seems to be the easiest way, because the other two are colorless. This is the only one that has color out of these three gases. Yes, we could have used a melting point, but that would be a lot harder to do, because we would have to have some solid chlorine, and then we would have to melt it and see what temperature it melts at, and so on and so forth. That'd be a lot harder. A colorless liquid boils at 40 degrees Celsius. Is the substance water? Why or why not? Okay. Well, I mean, what do we know about water? We know that water's melting point is 0, and we know its boiling point is 100 degrees Celsius. So, is water a colorless liquid? Definitely. Does it boil at 40? No. So, we know the substance can't be water, right? There is no way, no how, all right? If we're comparing all of these substances on here, that what they're describing is water. It can't be water, because water doesn't boil at 40 degrees Celsius. Which of the liquid substances has the highest melting point? So look on this list here. Which one of these has the highest melting point? Now we're just looking at the liquids, because it just says liquid substances. We're ignoring the solids here. So which of these liquids has the highest melting point? Now, you got to be careful. A lot of people see the number 117. They want to go with that, right? But that's negative 117, which is a really small number. 0 is the biggest out of these 4 liquids. Okay, so water has the highest melting point out of these 4 liquids. Which one has the lowest boiling point? So if you look at those 4 liquids, which one would you say? Probably bromine, right? Bromine only has a 59 degree boiling point. All the other ones are higher than that. And finally, which of the properties would be the most helpful in identifying an unknown substance? Right, so you've got 4 choices. We're just going with the information on this list. I know there are other properties out there that you might use, but just using the properties on this list. Is state of matter a good way of identifying a substance? Doesn't look like it. There are lots of things that are gases out there. So how could you identify which one it is just knowing its state? Or there are lots of things that are liquids. There are lots of things that are solids. That's not a very good thing to use. We could use color. But again, we're going to run into a problem because there are multiple things out there with the same color. So that's really not going to be unique enough to narrow down which one of these it is. Is there any of these substances that have the same melting point or the same boiling point as each other? I don't think so. And in fact, if we made an even bigger list with even more substances on there, I think you would find that there is no substances out there that have the same melting point and the same boiling point. So which of these properties would be the most helpful? Melting points and boiling points would be way more helpful than color or state of matter, right? Because they're much more unique. Speaking of states of matter, let's talk about the difference between solids, liquids, and gases, okay? This is one of those that really gets people when they start learning chemistry. And they're like, oh, I know what a solid is. I know what a liquid is. I know what a gas is, right? If I started putting substances in front of you right now, if we were sitting in the classroom and I came up to you at your table and I started setting things in front of you and I said, is that a solid or is that a liquid or is that a gas? I bet you 99% of the time you would have no problem telling me that. But then if I say, define what makes a solid, this is where it gets to be tricky. A lot of people know how to look at a solid and know what it is, but to tell somebody else how to find out what a solid is, what's the definition of a solid, that's tough. A lot of people say, oh, solids are hard. Are they? Could you have a soft solid? Like, for instance, is your pillow on your bed, is that solid? Yeah. Is it hard? I think most people would say no. So, there we go. That can't be the defining factor of what a solid is. Okay, so we're going to leave these second grade definitions, as I call them, out of the way. Right? A second grader might say, a solid is hard. But that's not a very good definition because it doesn't describe all solids. Solids always keep their same shape. If you don't do anything to them and you just leave them there, they are not going to change shape on you, right? Therefore, that makes them a solid. Also, their volume doesn't change. And so if you have a block of wood sitting in front of you, okay? If you have a block of wood sitting in front of you, if that block of wood would need to fit into a tiny little container, you wouldn't be able to do it because you can't squeeze and shape the block of wood into something else. Okay? Its shape can't change, its volume can't change, you can't compress it. It's incompressible. If you were to look at a solid up close, what would you see? Right? You would see these tiny little particles that make up the solid are all packed closely together. They're all moving slightly, but not a lot. Okay? We say they're vibrating, but they're really not moving much. And this is why a solid keeps its shape and its volume all the time. Now, what makes a liquid different? Think about it. If you use these as your definition parameters, right? Shape and volume. Is a liquid always keep the same shape no matter what? No. Right? If you pour a liquid into a different container, doesn't it take the shape of that container then? So it can change its shape. But does its volume change? No. If I give you 50 milliliters of water, and then I ask you to pour 50 milliliters of water into a container that can only hold 40 milliliters, guess what? It's going to spill all over the place because you can't fit 50 into 40. Its volume stays the same. How much space it takes up stays the same. But the shape of the container is the shape that it takes. It is also incompressible. You can't squeeze it into a smaller space. So again, how does it look different? Well, it doesn't stay in a nice, neat pattern. It isn't packed together quite as tight. They're still pretty closely together, but they can now move around a little bit easier. And then finally, how's a gas different? Is a gas's shape always the same? No, that totally depends on what container you put it in. How about its volume? That's the tricky one. Right? There's a lot of time. We don't know much about gases in our lives because most gases that we're around we can't see. And if we can't see them, we generally don't pay attention to them, right? You're surrounded by air right now, which is a gas, but you never really think about it, right? Gases actually take the shape and the volume of their container, which means they are compressible. You can squeeze a gas into a tiny little space, and you can make a gas fill up into a big space. And that's because gases do not stay together. They're always apart, flying around. So a physical change, we just mentioned physical properties. If you make a physical change to something, that's a change that does not affect the object's composition. So if you break something, right, you might have pieces of it, but you didn't affect what it's made out of, right? If you bend something, it might be a different shape than it was, but is it made out of something different? Nope. If you melt something, if I take an ice cube and I melt it, is it still water? Yep. Therefore, that's just a physical change. I didn't chemically change it. We're going to get into chemical changes a little bit later in this chapter. All right. So I want you to know the difference. What is a physical property? Right? So give me some examples of physical properties. How can they be useful to identify an object? What's a physical change that you could do to something and still keep it the same composition? And finally, what's the difference between a solid and a liquid and a gas? Important things to review.